Good morning, peace and goodness be with us all. Welcome to our Math Major 311 Number Theory subject. So, I am ChrisJJ Bench Seno, or you can call me Teacher Chris. I am your instructor for this subject. So, our learning competencies at the end of the lesson, the students must be able to identify the given equation with the given system of linear congruence has a solution or does not have. Comprehend the common concepts used in the system of linear congruence. Solving systems of linear congruence. So, before we move to our introductory activity, can someone recall about your previous topic, which is in line in this subject? Anyone? Just give it a try. I know one. Okay. So before, as you remember, you tackled about the primes and greatest common divisors and prime factorization, which are the prime numbers, greatest common divisor, the Euclidean algorithm, the fundamental theorem of arithmetic, linear Diophantine equation. And now, we will discuss about the congruences. So, before we go deeper with our topic and our discussion for today, so I prepare an introductory activity that will serve as your guide to our main discussion, So, it is called Pick a Number. So, teacher will ask students to divide the class into 4 groups. Once the class is already divided into 4 groups, the teacher will ask each group to have a group representative. Once they choose a group representative, the teacher will ask one by one to pick a number from 1 to 10 and no repeating of numbers to be picked. From the number they choose to pick, there is a corresponding jumbled letters that the teacher prepares for them and they need to come up with the correct word. And each group must prepare a short yell, 3 to 5 seconds, as an indication that they already arranged the word accordingly. So, are you ready? Kindly form your 4 groups right now so that you can now pick your number. So, are you ready? So, here is the jumbled words. So, group 1, which number would you choose to pick? Number 3, okay? Group 2, number 5. Group 3, number 7. And last group, number 8, okay? So, you can now start assembling your chosen number. I will give you 20 seconds or 30 seconds to complete the words. And don't forget the instruction that I gave you a while ago. So your 30 seconds starts now. So are you ready? So let's now check your work if it is correct. So group number 1. Yes, it is correct. It is summation. Group 2. Yes, it is modulo. And group 3, it is greatest common divisor. And last group, yes, exactly. It is the linear congruence. So, do you have any idea what is our topic for today? Anyone? So, since you don't have any idea, I will just straight to the point. So, since you don't have any idea, I will now proceed. So, our topic for today is the systems of linear congruence. So, systems of linear congruence. It provides a fundamental relationship between integer linear combinations of numbers and their GCD. It showcases some of the finer points of modular arithmetic, like a number is invertible if it is co-prime to n. Otherwise, it is a zero divisor. This can allow you to count how many solutions to each equation there are. So a problem of finding an integer x that satisfies the equation of ax is equal to b mod m. A linear congruence is a congruence in the form of ax is equal to b mod m, where x is an unknown integer. In a linear congruence where x0 is the solution, all the integers x1 or x1 is equal to 0 mod m. So if n is a positive integer, we say that the integers a and b are congruent modulo n, and write a equivalents b mod n if they have the same remainder on division by n. Can be solved using methods from linear algebra, which is the matrix inversion, Cramer's rule, or row reduction. In case the modulus is prime, everything you know from linear algebra goes over to systems of linear congruences. The reason is that ZP is a field where P prime and linear algebra works fine over any field, not just R and C. So to solve a linear congruence AX equivalence B mod n, you can multiply by the inverse of if GCD AN is equal to 1. Otherwise, more care is needed. And there will be either be no solutions or several exactly GCD AN total solutions for X mod n. So let G is equal to GCD AM. If B is not divisible by G, there are no solutions. If B is divisible by G, there are G solutions. So let's proceed to our first example. So solve for the following system of linear congruence. X equivalents to 8 mod 12 and X equivalents to 6 mod 13. From the first linear congruence, there exists a KL belongs to Z such that X equivalents to 8 plus 12 KL. Substituting this into the second linear congruence give us 8 plus 12 KL equivalents to 6 mod 13. So 8, let's transpose positive 8 to the right side. So this will give us 12 KL equivalents to negative 2 mod 13. And 12 KL equivalents to 11 mod 13. Notice that 12 and 13 is equal to 1 and 11, so there exists a solution. Let's use the division algorithm to find the inverse of 12 modulo 13. 13 is equal to 12 times 1 plus 1. So 12 is equal to 1 times 12 plus 0. So 1 is equal to 13 plus 12 times negative 1. So hence we can use negative 1 as our inverse. Thus, negative 1, 12 KL equivalents to negative 1, 11 mod 13. So KL equivalents to negative 1, negative 11. So KL equivalents to negative 11 mod 13. So KL equivalents to 2 mod 13. So hence, for some K2 belongs to Z, KL is equal to 2 plus 13 K2. Substituting this into our equation for X yields, X is equal to 8 plus 12 times 2 plus 13 K2. Will give us X is equal to 32 plus 156 K2. Thus, it follows that X equivalents to 32 mod 156, so X is equal to 32 is the solution to this linear congruence. Now, let's move on to our second example. Solve for the following system of linear congruence, where X equivalents to 3 mod 7 and X equivalents to 7 mod 12 and X equivalents to 4 mod 17. Since all of the modular are relatively prime, we know that by the Chinese remainder theorem that this system of linear congruences has a solution modulo to the product of the moduli from the first linear congruence for some k1 belongs to z, we have that x is equal to 3 plus 7 k1. Substituting this to the second congruence, and we get that 3 plus 7 k1 equivalents to 7 mode 12. Let's transpose positive 3 to the left side, and this will give us 7k1 equivalents to 4 mode 12. By inspection, we can see that 7 can be used as an inverse to 7 modulo 12, and thus 7 times 7k1 equivalents to 7 times 4 mode 12. So k1, so since all the constant number will be transposed to the right side, this will give us k1 is equal to 28 mode 12, and k1 is equal to 4 mode 12. And for some k2 belongs to z, we have k1 is equal to 4 plus 12 k2. We can substitute this back into our equation for x to get that x is equal to 3 plus 7 times 4 plus 12 k2 is equal to 31 plus 84 k2. And substituting this into our last linear congruence give us 31 plus 84 k2 equivalents to 4 mode 17. So 14 plus 16 k2 equivalents to 4 mode 17. And the positive 14 will be transposed to the right side. This will give us 16 k2 equivalents to negative 10 mode 17, and 16 k2 equivalents to 7 mode 17. Hence, we must find an inverse of 16 modulo 17, which we will once again obtain by inspection. We note that 16 will work. Hence, 16 times 16 k2 equivalents to 16 times 7 mode 17. And let's transpose the constant number to the right side, and this will give us k2 equivalents to 112 mode 17, and k2 equivalents to 10 mode 17. And when we substitute this back into our equation for x to get that, x is equal to 31 plus 84 times 10 plus 17 k2 is equal to 871 plus 1428 k2. Hence, it follows that x equivalents to 871 mode 1428. So our solution is thus x is equal to 871, which satisfies all three congruences. Anyone? Do you have any questions? So since you don't have any questions, I will give you an activity. It is a group activity. So the class will be divided into two groups. Each team will be given a manila paper or a cartolina on which they can write their solutions, and they will also be given a marker. So to show their answer and discuss the solutions they gather and being provided. So each group must have a representative to explain their answers and discuss it on class. So 15 minutes to finish the activity. So now I will be divided the class into two. So this is group 1 and this is group 2. So for group 1, this will be your equation. So kindly copy. Solve for the following systems of linear congruences: x equivalents to 1 mode 6 and x equivalents to 17 mode 39. And for the group 2, here is your equation. So solve for the following system of linear congruences: x equivalents to 8 mode 12 and x equivalents to 6 mode 9. So I will give you 15 minutes, and your 15 minutes will start now. Time is up. Let's now check your work. And for your assignment, read and study in advance the next lesson found in your textbook, or you may watch it on YouTube with this following link being provided. That's all for today, everyone, and I hope you learned today. Thank you and God bless.